Let's go to the elimination method. Now, the elimination method really, if I can just explain briefly, um, if you have equations like in this example here, y is equal to 2x minus 1 and y is equal to negative x plus 5, in the elimination method, you need to identify a variable that you want to eliminate. And to do that, you have to look at both equations. So someone else would have looked at these two and said, oh, I'm going to eliminate y. Or someone else would have decided, oh, I'm going to eliminate the variable x. But to eliminate that variable, you must do certain things that still maintains the mathematics of it and not just make it disappear. So how then do you eliminate a variable in this? Ultimately, you have to get to a step where you have to add the two equations. Now, in order to eliminate that variable during the addition of the two equations, you must have a situation where your two variables have similar coefficients, but the other one must be negative. Okay. Now, that's pretty easy to do. If I look at this one, I can target y. And if I target that I'm going to eliminate y, that means the other y must be negative. So I then need to do something to fix exactly what I want to see coming out. I want that y negative. I'm going to multiply that y and multiply all the terms in the equation with a negative 1. And that will then give me the y that is negative. It won't change the equation because I've multiplied both sides of the equation by the same thing. Someone else would have decided, oh, I want to eliminate x. Now, can you see if you look at the x's there? The other x is positive 2x. The other x is just negative x. So if we had multiplied equation 2 by 2, all of those terms by 2, would have ended up with negative 2x in the second equation. It would have been good enough to actually eliminate the variable x and end up with 2x and negative 2x in the other one. So you always have to look at the variable you're dealing with. Never worry about the other terms, what would come out once you multiplied. You want to eliminate that specific variable, deal with it, and apply what you need to apply in order to eliminate it. So equation 1 stays as it is. Equation 2, I'm going to multiply everything there by a negative. So I end up with negative y. I end up with positive x. I end up with negative 5. Now my y's will be eliminated easily when I add the 2 because I've multiplied the second equation by negative 1. Now let's add. If you add, the y's give us 0. 2x plus x gives us 3x. Negative 1 and negative 5 gives us negative 6. If you've done everything correctly, you should end up with an equation with only one variable. And there we can see that because that's exactly what happens when you've eliminated the other variable. So now solve for x. 3x is equal to 6, your x is equal to 2. Very easy. But then we're not done because we only have x. We need to go find y. So you go to any one of the two equations, substitute your x, and you get your y. So in this case, I've gone to equation 2, substitute x as 2, your y is equal to 3. Let's take another example on the elimination method. Again, we're given equations 2y is equal to x minus 3 and 3y is equal to negative 2x minus 1. Now, remember again, you need to identify a variable to eliminate. Now, when I look here, I notice that the 2y and the 3y's, the y's are not helping me. They've got completely different variables. I'll have to do more to eliminate them. And I look at the x's and I realize, oh, the other one has got negative 2x, whilst the other has got just x. So if I had just multiplied this one by 2, I would be able to get 2x there and get negative 2x, and the 2 would eliminate easily when I add the two equations. But then in order to make that x positive 2x, I need to multiply all terms of that equation by 2. So multiply the first equation, equation 1 by 2, I get 4y, 2x minus 6. And then bring the second equation. I'm doing nothing on it because I already have what I want. I will be able to eliminate the x variable. Add. You get 7y equals to negative 7. The 2x and negative 2x gives us 0. Now divide both sides by 7. And your y is equal to negative 1. So can you see in this one we start getting y first. So there is no rule that says first you must get x, then you get y. No, it just depends what is it that you've done in your equation, and you get the variable, then go find the other. So now we need to go find x because we've got y. Pick an equation. I'm going to equation 1, substitute y as -1, and solve for x. My x equals to 1. It's a very easy thing if you understand and follow the skills and the calculations properly. And also your knowledge of how to solve equations is very important. Let's have a look at example 3. We're still on the elimination method. Now, we've got here 4y is equal to 5x plus 1. Y is equal to 2x minus 2. Again, you want to look very carefully. Which one do you want to eliminate? Do you want to eliminate the y, or do you want to eliminate the x? In this case, I'll go for y. I would go for y because I can already see that, oh, one of the important things here is I already have a 4y. I can just multiply the bottom equation, equation 2, by -4. But I must multiply all the terms by -4. So I keep equation 1. I multiply equation 2 by -4. I get -4y. I get -8x. I get +8. Oh, now I'm ready to eliminate. Add the two equations. I get 0 equals to -3x plus 9. Solve for x. And your x equals to 3. Now we've done with the x. We need to go find the y. I'm going to go to equation 2. Substitute my x in there, and my y is equal to 4. Okay, so very easy, as long as you follow the correct method in correct way. I think what's crucial with this method is that you need to identify the variable and do the necessary calculations to get that variable to be eliminated. And it's all about the coefficients of the variable you've identified. Example 4. Here now, just like in a test or an exam, you can get an equation saying, or question saying, solve for x and y in 3y is equal to 2x minus 5 and 2y minus 3x minus y. Or you could actually get an equation saying, solve the following equations simultaneously. But you would know the story. It means find x and y of the two equations. Well, let's have a look. What I've done here, if you notice, my first equation stays as it is, 3y is equal to 2x minus 5. But my second equation, I've fixed the question that was given because I wanted to write my equation in such a way that the y is below the other y, the x is below the other x, and the constant term is below the other constant term. So that when I do my addition of the two equations, I'm able to eliminate the variable I want to eliminate. That's very, very important. So we fixed the second equation. That's why you see there's a positive 3x and there's a positive 1. Secondly, now I must identify my variable. I look at the y, I see completely different coefficients. I look at the x, same story. And here really it's like one of those equations. It doesn't matter which variable you've identified, but you're going to have to do the same thing. Now, there's no way we can multiply 3 by something to give us 2 without going through some decimals or some fractions. So we then need to avoid that. The same thing happens with the 2 if I'm identifying y as my variable to eliminate. So in order then to eliminate that variable, I need to make sure that the two terms have got the same coefficient. And this is where now the lowest common multiple of the two values that are there already would help us. So there's 3 and there's 2, and therefore 6 is what we're targeting. We want to make sure that the other one has got positive 6y and the other one has got negative 6y. So I've gone and multiplied equation 1 by 2 so that the 3y could end up being 6y. But then I must multiply all the terms. That's why I've got 4x minus 10. I go to the second equation. I multiply that by -3 so that the 2y that we had ends up being -6y. Now I can now then add my two equations. I've multiplied all the terms correctly by -3. Add the two equations to eliminate the y, and I end up with an equation of -5x minus 13 is equal to 0. Now solve for x. My x is equal to -13/5. Now let's use that x value to go find the y value. Now remember again, you can pick any of the two equations when you substitute the value that you've already found. So in this case, we've gone to the second equation, equation 2, substitute x as -13/5. Make sure with your fractions there, and we divide both sides by 2 or multiply by half, and our x is -34/10. But remember again, we never leave our answers like that. They must be in their simplest form. So we leave that answer in the simplest form of negative 17 over 5. Okay, so these are pretty easy and straightforward ways of doing your calculations when solving equations simultaneously. And really, if you get it right, you'll never have a problem. All right.